Alright, determine algebraically whether the functions are even, odd, or neither. To determine one of these, I'm going to have to make sub negative x for x. So every x value, I'm going to put in negative x. So there is an x. There's another x. And this last x. And then I'm going to use exponents, so negative x times negative x times negative x is negative x to the third times 2 is negative 2x to the third power. This becomes a positive 3x. Notice how this is not the original problem, so it's not even. Now I'm going to factor out a negative 1. If I factor out a negative 1, negative 1 times something will equal negative 2x to the third. Well, that'll be 2x to the third. Negative 1 times something will equal positive 3x. That is negative 3x. I'm going to look above here in this parentheses. Is that the original problem? Yes, it is. So I have f of negative x equals negative f of x. And that's why I have this phrase called odd x. You substituted negative x, and I say odd x, you get the original problem, it's going to be an odd function. If I use end behavior to kind of give myself a quick sketch, the highest degree is the power of 3. That is an odd. Odds look like linears, right? X to the first is an odd. So I know I'm going to start down and up. Because it's to the third power, it's cubic. If you actually factored it out, pull out an x, you'll get 2x squared minus 3. And you set each of those equal to 0. You would have gone x equals 0 and x equals plus or minus radical 3 over 2. So your graph might look something like this. One, two, yeah, that'll work. And notice how if you graphed it something like this, to check that it is symmetrical around the x-axis, you'll just look going across, small bump, small bump. One line, one line.